Ants and aphids have a fascinating and complex symbiotic relationship that showcases the intricate interdependencies in nature. This mutualistic association, where both parties benefit, is a classic example of how different species can evolve and adapt behaviors that enhance their survival and reproductive success. Aphids are small sap-sucking insects that feed on the phloem of plants. As they feed, they excrete a sugary substance known as honeydew, which is rich in carbohydrates. Honeydew is a byproduct of the aphid's digestion, and it can accumulate on plant surfaces, creating a sticky mess. While honeydew might be a waste product for aphids, it is a valuable resource for ants. Ants have a high demand for sugars to fuel their energy-intensive activities, and honeydew provides an abundant and readily accessible source of this essential nutrient. The relationship between ants and aphids begins when ants discover a colony of aphids. Attracted by the honeydew, ants will protect and tend to the aphids, creating a mutually beneficial arrangement. The ants provide protection to the aphids from predators and parasitoids. Aphids are vulnerable to a variety of natural enemies, including ladybugs, lacewings, and parasitic wasps, which can significantly reduce aphid populations. By defending aphids against these threats, ants help ensure a steady supply of honeydew for themselves. In return, the aphids benefit from the reduced predation pressure, which enhances their survival and allows them to reproduce more successfully. Ants exhibit several behaviors to protect their aphid partners. They patrol the plants where aphids are feeding, warding off potential predators through aggressive displays and physical attacks. Some ant species go to the extent of building shelters over aphid colonies to shield them from the elements and hide them from predators. These shelters can be constructed from soil, plant debris, or even by manipulating the plant itself. Additionally, ants will often move aphids to more favorable feeding sites on the plant, ensuring that the aphids have access to fresh, nutritious sap, which in turn maximizes honeydew production. Beyond protection, ants engage in direct care of the aphids. They use their antennae to stroke the aphids, stimulating them to excrete honeydew. This behavior, known as milking, is essential for both parties. The aphids receive regular attention and protection, while the ants harvest the honeydew to bring back to their nests. This constant interaction ensures that the aphids remain productive and the ants remain well fed. The mutual benefits of this relationship extend beyond mere survival. For aphids, being tended by ants can lead to increased reproductive rates. Protected from predators and with access to optimal feeding sites, aphids can reproduce rapidly, sometimes resulting in large, thriving colonies. This reproductive success can be partially attributed to the reduced energy expenditure on defense, allowing aphids to allocate more resources to growth and reproduction. The mutualism between ants and aphids can also influence the broader ecological community. The presence of ant-tended aphid colonies can alter the dynamics of plant-predator interactions. For instance, plants harboring aphids might suffer from increased sap extraction, leading to reduced vigor and growth. However, some plants can tolerate or even benefit from the presence of aphids if the ants deter more harmful herbivores. The relationship between ants and aphids can thus have cascading effects on plant health, competition, and overall ecosystem functioning. Interestingly, not all aphid-ant interactions are strictly mutualistic. There are instances where the relationship can shift towards parasitism or exploitation. For example, some aphids can become overly dependent on ant protection, to the point where they lose their natural defensive behaviors and become less capable of surviving without their ant partners. In contrast, some ants may exploit aphids by over-harvesting honeydew or neglecting their protective duties, leading to increased aphid vulnerability. These variations highlight the dynamic nature of mutualistic relationships, which can fluctuate based on environmental conditions, population densities, and the specific species involved. On the other hand, there are cases where the mutualism can be harnessed for biological control. Some ant species prey on other insect pests or disrupt their activities, providing a form of indirect pest control. By fostering a balance between beneficial ant activities and their aphid-tending behaviors, it is possible to develop more sustainable agricultural practices that minimize the need for chemical pesticides. In summary, the symbiotic relationship between ants and aphids is a prime example of mutualism in nature. Through protection and care, ants ensure a steady supply of honeydew, while aphids gain enhanced survival and reproductive success. Thanks for watching. Subscribe for more.